So, if you guys remember from a month and a half ago, Artemis 2 successfully circumnavigated the moon, including the far side of the moon, making it the furthest distance humans have ever traveled from Earth since the Apollo missions. But this mission did not land, but it was a tested critical life support navigation and spacecraft system mission to pretty much lay the groundwork for the future of lunar travel, but also lunar colonization and lunar settling by building these lunar bases. Basically, the Artemis 2 crew has pretty much circumnavigated, went around the moon, discovered many points on the moon, showing the sites for possible moon bases. So, understanding with all that information that we have now from Artemis 2, with the 1,200 new photos that are released from the Artemis 2 crew, now let's talk about the possibilities of the moon base. What ways can we build a moon base in many phases? We're going to go over that and understand why we're going to be building moon bases and establishing permanent settling on the moon. So let's talk about it. So let's talk about it. We're going back to the moon in 2028. The first moon landing in that time in 2028 will mark 56 years since humans first actually stepped foot on the moon. Since 1969. From 1969 to 1972, we had 9 moon landings. But it wasn't at the South Pole, it was actually on the Sea of Tranquility. But this time it's going to be different because in 2028, we're Artemis 4, we're setting our sights on the South Pole of the moon. The reason why we're going to the South Pole this time is because these are areas where sunlight can't hardly reach that area. Also, these are areas where we have cliff-like structures that are so high, but also crater structures that are very deep, hiding the potential for water ice, tons of water ice that's locked up in deep, 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 hundreds of, if not probably thousands of feet deep in these craters, again, where sunlight can't reach that area. But also, understanding how we can survive in the sweltering heat, because the sweltering heat can go up to 200 degrees Fahrenheit, but also survive the nighttime, because in the nighttime we're actually can get down to negative 200 degrees Fahrenheit. So we're going to understand how volatile humans can survive in a wild temperature swings, and but also importantly, because it hides the crucial elements that we need: water, water ice. And why water ice? Well, because water can be used for basic human needs like food, water. But also, that's so important to go to Mars one day after we understand the moon, using the moon as fuel. And rockets use hydrogen and oxygen. Well, what is water made out of? H2O. 2 hydrogen, 1 oxygen. And you break those apart and you put separate containers that contain the hydrogen, but also the oxygen, and will create the combustion it needs for the rocket. Yes. So sustaining just enough water and building enough fuel for the humans, but also the rockets that's going to be used for Mars. So now it brings us to many phases of how humans are going to be surviving on the moon once we start landing on the moon. So from now to 2028, from now to Artemis 4, we'll have the first crewed landing for Artemis 4 in 2028. So this mission is to land on the surface, land on the South Pole, and pretty much deploy rovers, drones, and satellites to test the mobility and communications and perform surface operations by collecting different moon samples, learning about the entire geography of the South Pole, mark the territories, figure out where water could be possible in these rims in these deep craters by mapping and performing moon technology operations using the drones that have uh, pieces of technology used for like GIS, right? You go to GIS systems where they have create maps and mosaic these maps, and then they add code and they pretty much add the colors to know where is the possible locations for this area. And using the technology to use onto these drones, it's critical to put it onto the, launch it on the moon to map out where water could be present in this location. So next one is to deploy the rovers. You know, understanding how rovers are going to be withstanding the temperature differences, but also including the radioisotope heater units, the RHUs, the early nuclear power systems to survive the lunar nights. So because again, the lunar South Pole can reach temperatures below 240 degrees below zero, right? And it's very important to sustain heat by using nuclear power uh, fusion to help the astronauts survive the lunar nights because it's so cold. You know, Apply enough heat to sustain for the astronauts. So now we're going to deliver approximately 4 tons of payload to evaluate technologies and operational procedures. Basically, how we can sustain the equipment that they need, drone technology, food, water, and basically backup batteries for these rovers, and other types of technology like computers, phones, etc., etc. 4 tons of payloads that can be shipped from Earth to the moon. Remember, it's just a 3-day mission to send the technologies and get it to there as possible. So that gets us to phase 2. Phase 2 will be from 2029 to 2032, the earliest infrastructure and semi-annual crewed missions. This is where we start ramping up from the first few humans on the South Pole of the moon to bringing more people and more payloads and other stuff, but also building the payloads to build the infrastructure onto the moon. So building a semi-permanent habitat in infrastructure for extended human activities by solar arrays, nuclear powered systems, and communication networks like satellite dishes and satellite domes, where we can communicate back and forth from Earth to the moon. Remember, because the communication between Earth and Moon takes about 1.25 seconds, if you didn't know. So that has a 1.25 communication delay, but we'll understand how we can power grids that can work these mobile communication networks to build faster communication technologies faster. Kind of, but there still be a little bit delay, still, but it's still 1.25 seconds. But we can build something that can be a little bit faster because we want to say there if there's an emergency somewhere and we have to figure out how we can help the astronauts in need if they're injured or if they need to perform something. Let's see, solar arrays. How it can power those early infrastructures for building these bases, these labs, the communication, etc. Using the sunlight power from the near side of the moon. Whatever sunlight's left, so they can harness the energy and power up these stations. Deploy pressurized rovers for mobile habitats, enabling 2-person surface expeditions, delivering up to 60 tons of cargo through a 24 landings, and supporting logistics, power, and science operations. So building, the labs, building the power that we need. So that takes tons of payloads and different other missions that can bring all that stuff, to build these labs, build early habitats and the mobile communication systems. So phase three for 2023 to 2036 and beyond, sustained human presence. Yes, establishing the permanent bases, not just having humans, stay out for like 2 to 3 days on the moon. No, this is we're talking about building sustainable habitats for humans to survive up to at least a year and beyond on the moon. Can you imagine that? I mean, but again, that's still planned because again, you have to understand the human psychology, physiology, and etc. Basically what humans go through. Like mental health, etc., and physical health, etc., etc., and everything that we need for our bodies, right? We need to have that discussion in the long run for phase three because again, you're 3 days away from home, but if say we want to go to Mars, that will be 6 to 9 months from home. But it depends because Mars and Earth are not in the same part, on the same sides of the sun, because they're in completely different orbits. Because the time it takes to travel will take a couple years. Because again, you need to understand that Earth and Mars again, you're not in the same path. But we want to understand this on the moon because the moon will only just take 3 days to get to, 96 hours back and forth. So understanding you're 3 days away from home, we want to understand how it, maintains for the humans, for our mental health or physical, etc. That's kind of what we need to have a discussion on for phase three by 2033 and 2036, right? All right, Operation Fission surface powered stations and advanced logistic networks. So again, creating nuclear fission to pretty much provide heat for our rovers and the humans that are going to be on the South Pole surviving lunar nights, and understanding how we can provide the heat for the domes and make it habitable for people in these domes. Because we need heat, we need cooling, because again it does get hot, because remember it's 14 days a day, 14 days a night. So we need to understand those temperature swings. We need cooling, we need heat, and we need logistics and networks because we need to communicate back and forth 1.25 seconds. Anyway, we need to enable long duration explorations. We need to resource extractions, water, oxygen, and helium-3, and the preparations and planning for Mars. Exactly. So understanding the geography is very important for the first phase. Now we're actually going to be learning that geography and applying it to when we use our rovers and use our drones, use our digging equipment to provide samples and obviously start digging in these areas for that water. And then we can understand the chemistry because we need chemists there that can break apart our hydrogen and our oxygen, and we can sustain that and fuel up our rocket. And this is in preparation for Mars. And understanding that as we get more payloads, because it will take another 150 tons of payload annually, including the next crew missions and uncrew vehicles like drones, rovers, etc., and other rockets that can sustain, that need food, water, supplies, and technologies, etc., etc., etc. So we need key technologies and infrastructure. So power systems, solar arrays, nuclear fission reactors, and radioisotope thermoelectric generators, RTGs, and continuous energies for our moon bases. We need mobility. We need lunar terrain vehicles, LTVs, pressurized rovers, and autonomous drones for exploration and logistics. And these are rovers that have like the GIS technologies, and we can, use GIS to pretty much map out the lunar south pole to understand where water is contained. Communications, again, communications back and forth, 1.25 seconds. In situ resource utilization, extraction of water, oxygen, and other materials from the lunar regolith for life support and fuel production for rockets, but also life support for humans, like basic needs like water, food, medical, etc. So yeah, pretty much that's very important. So now we're gonna get to the next chapter. Other countries that are gonna be joining us with, especially in this moon race, right? Because we're in a moon race with China. Because China, this weekend has pretty much sent astronauts to 1 year to China's space station to spend 1 year before they go to the moon. So we want to understand that we need to go to the moon before China does, or before India, before Russia, before other countries are joining in by this time period. Because we're talking about in the 2030s, we're talking about the 2040s and beyond. Other countries are having interests and joining the exploration of going to the moon and going to Mars one day. So we gotta understand when we have humans like from other countries, we need to learn how about survival on the moon first before we actually understand and basically add the treaties. We need to understand the survival. We need to understand the surface. We need to understand the capabilities, the human human health, etc. We need all of this to survive first. Before we even build permanent settlements in other countries are building it too, we need to learn about survival first. And then when we get to our permanent settlements, we'll start sustaining how much square miles of land that we need abided by a certain treaty. Because there's treaties like there's things you can't contaminate. There's you'll get one section of land, right? One country gets their own section of land, just like how Antarctica, again, it's divided into multiple research stations from different types of countries because they have their own treaties that can pretty much say, hey, that if I have a country that says, hey, we want some resource from this one, well, according to this treaty, that you only have abide by whatever section of land that you are issued, and this is your land, this is your type of resources. There's things that you can't contaminate. There's things that you have to abide by. So those are some of those treaties that I have to understand. But we just need to learn about survival first before we even get into the geopolitics of permanent settlements on the moon. So yeah, I'm gonna probably explain some more about this and more research. But yeah, well, thank you guys so much for watching this podcast about lunar bases, understanding the three main phases and components that we need for livability and sustainability for the south pole of the moon. Because again, this is kind of because I was watching the live stream from NASA about the whole moon base project, and this is kind of what's kind of talking about. Each phase will understand this. We'll go from now to 2036 and beyond, and understanding about sustainability, human vulnerabilities, like understanding the human, psychologically, physiologically, just understanding the human capabilities, understanding how other countries are going to get involved, talking about understanding how we can actually start continuously building up and up until we start building the permanent human settlements for humans to sustain a year and beyond. And then how we can use that technology of using, for humans for like consumption, etc., and medical, and then building rockets out of the lunar water and, making lunar infrastructure like roads and highways, out of the lunar regolith, etc., etc. And that's kind of what's important before we go to Mars, because we want to understand the survival of Mars, because this is a different environment with a different biome with different categories of how things are and how we can sustain life forms on a different planet, become a two planet species. So yeah, I mean that's what the plan is for in the future beyond. Because hey, I mean hopefully by 2050 we can probably one day we can go to Mars. I mean that's what's predicted by Elon. By 2050 we can go to Mars. Well, again, it's still very difficult. But again, we want to understand the moon first before we even set foot on Mars. But yeah, thank you guys so much for watching. I'll see you guys in the next video. Bye.